Hello and welcome. Okay, imagine you're scrolling online and you see this little notice. It says wanted volunteers for a study to find out which of two leadership styles works better. That is it. That's the whole thing. No details, no plan, just two leadership styles. And here's the thing, that one tiny notice is hiding about a dozen problems that could sink the entire study before it even begins. In this video, we're gonna take that exact scenario apart, piece by piece, and then I'll show you how a real researcher would do it right, all the way down to a corner of statistics most people have never heard of, called nonparametric analysis. Let's get into it. So, here's our roadmap. This is the science of sound conclusions. And I know the word statistics makes a lot of people want to close the tab. Stay with me because this isn't really about math, it's about trust. It's about how we decide whether to believe a claim like this leadership style gets better results. Over the next few minutes, we'll cover 7 big ideas. Why your method decides whether anyone should believe you. The most common ways studies fall apart. How you turn a fuzzy idea into something you can actually measure. How you pick the right people to study and how many. The difference between parametric and non-parametric tests. How to check your data and catch the weird values. And finally, a simple decision framework for choosing the correct test every single time. By the end, that work little notice is going to look completely different to you. Why methodology matters. Let's start with the big picture. Why does method matter so much? Here's the one sentence version. A conclusion is only as strong as the design that produced it. Think of it like building. Look at this pyramid on the screen. At the very top, you've got the thing everybody wants, credible conclusions. But that top block is sitting on valid inference, which sits on reliable measurement, which sits on rigorous design at the foundation. If the bottom layer is shaky, everything above it comes tumbling down. It doesn't matter how fancy your charts look. And researchers actually break this down into a few kinds of validity. There is internal validity. Are the effects you are seeing real? Or just an accident of how you set things up? External validity. Do your results apply to anyone outside your little sample? Construct validity. Are you measuring what you think you are measuring? And statistical conclusion validity. Are the numbers actually justifying what you claim? Two more. Your study has replicable. Somebody else should be able to repeat it and get the same answer. And it should be transparent. You say what you are gonna do before you do it. So you can quietly change the rules halfway through. Hold on that idea. It comes back in a big way. Common design flaws. All right, back to our notice. The two leadership styles one. This is the part where I get a little bit of a detective. Because once you know what to look for, you start spotting the cracks everywhere. There are 7 of them. One, undefined variables. Two leadership styles. Okay, which two? What do they actually look like? Nobody says. Two, self-selection bias. It's asking for volunteers, but people who volunteer are usually different from everybody who doesn't. So right away, your group isn't representative. Three, the Hawthorne effect. This is a great one. People change their behavior simply because they know they are being watched. We all do it. Camera comes on, we sit up straighter. Four, a missing timeline. How long are people exposed to this leadership? A day, a year, it doesn't say. 5, no operationalized outcome. Which one works better? But better is never actually defined. Better how? 6, no power analysis. That's a fancy way of saying nobody figured out how many people they actually need. 7, no analysis plan. They haven't decided how they all crunch the numbers, which means they can pick at the data and pick whatever test makes them look good. And here's the kicker. Any one of this is enough to undermine the whole study long before a single number gets analyzed. So that's concern number one, fully on the table. This notice has almost no detail, no structure, no procedure. Now, let's talk about what is missing. Operationalizing variables. The first thing that's missing, clear variables. In research, you've got two main players. The independent variable, that's the thing you are changing or comparing. Here is the leadership style. And the dependent variable, that's the result you are measuring, the performance, the outcome. The problem with our notice is that both of these are basically undefined, and you cannot just leave them vague. You have to operationalize them, turn the fuzzy idea into something concrete and observable. So instead of leadership style, a good study would anchor it to a real, established framework. Look at the three cards on screen. There's transformational leadership, the inspiring kind, the one that elevates and motivates people. There's transactional, clear expectations, rewards for hitting targets, a trade, and laissez-faire, which is basically hands off, passive, sometimes just absent. See the difference? Those are three distinct things you can actually point to, not a vague style A versus style B. And notice that's already three groups, not two. You shouldn't squish real different styles into one lazy either or comparison. Same goes for the outcome. Don't just say performance, pair it with hard numbers, goals achieved, output ratings. So it is measurable, not just a vibe. Let's see sampling and statistical power. Next missing piece, who are you studying and how many of them? Or notice it just says volunteers, but a strong study is way more deliberate than that. Ideally, you want probability sampling, where every person in your target group has a known fair chance of being picked. Even better, stratified sampling, where your sample mirrors the real population. So, if the real works is, say, frontline workers, middle managers, and senior leaders, your sample should reflect those same proportions. And you randomly assign people to groups so any hidden differences get balanced out. Now, the how many question. This is where statistical power comes in. And I love this part because the picture says it all. Look at this curve. On the bottom, that is your sample size. How many people going up? That's your power. Basically, your ability to actually detect a real effect if one exists. See how the line climbs steeply at first and then flattens out. There's a sweet spot, that dot, the minimum number of people you need to hit the standard benchmark, 80% power at the usual cutoff. Below that, your study is underpowered, meaning even if their leadership effect is totally real, your study might just miss it. And then wrongly conclude nothing's there, when really you just didn't bring enough people. That's tragedy in research, and it is completely avoidable. You run the numbers before you start. Here we go, parametric versus non-parametric. Okay, here's the heart of the video. The part the whole thing is named after. When it is finally time to analyze your data, you have to pick a test. And tests come in two big families. One, the left parametric test. The name's a little intimidating, but the idea is simple. Parametric tests assume your data flow and non well behaved pattern, usually that nice symmetric bell shape. They work with precise numeric measurements. They compare averages, and when those assumptions are true, they are the most powerful option you've got. The classic are things like the t-test and ANOVA. On the right, non-parametric tests, these are the flexible cousins. They make no assumption about the shape of your data. They happily work with rankings and ordered categories. They compare medians and rank order instead of averages. And this is the key. They are tough, robust, outliers, and weird. Lopsided data don't break them. So, how do you choose between the families? It comes down to a deciding question. Are your assumptions met? Is your data truly numeric or is it really just ordered? And here's the one to remember for the rest of your life. Those 1 to 5 strongly agree to strongly disagree surveys, those Likert scale ratings, their data is ordinal. It's ranked, not truly numeric. The gap from agree to strongly agree isn't necessarily the same as natural to agree. And that very often points you straight to non-parametric. This is exactly the kind of decision our work leader notice never even thought about. Let's see testing normality. So, how do you actually know if your data is well behaved? You test it. This is the gatekeeper step because normality, whether your data forms that bell shape, decides whether you are even allowed to use the powerful parametric test. There are two formal tests for this. The first is the Shapiro-Wilk test. It's the go-to, and it works great for smaller to medium samples. The second is the Kolmogorov-Smirnov test. Say that 5 times fast, which tends to get used to for larger samples. Both of them give you a result, and there's one simple rule to read it. The result is above the 0.05 cutoff. Your data is basically normal. You are good for parametric. If it is below, that's a red flag. Your data isn't behaving and you should lean non-parametric. But, and this matters, don't only trust the numbers. Look at this picture too. Here's the bell curve. You can drop your data onto a histogram and see if it forms that shape. You can use a P-P plot or a Q-Q plot, where if your data is a normal, the points line up nearly along the diagonal. Notice the red tails on the edges of this curve. When those tails get fat, or the whole thing leans to one side, that's your data telling you the bell-shaped assumption doesn't fit me. Numbers and pictures, always both, never just less detecting outliers. Now, before you trust any of these, you got to hunt for outliers. Outliers are those one or two extreme values that are way out of line with everything else and they cause real damage. They drag your averages around, they inflate your variability, and they can flat out break a parametric test. So, how do you catch them? Two main tools. First, the z-score. You standardize every value, basically asking how far is this point from the average, and the rule of thumb. If a value scores below -3 or above +3, like those red dots out on the edges, you flag it as extreme. Second tool, the box plot. Look at this one on screen. The box in the middle holds the bulk of your data. The line in the middle is your median, and those whiskers reaching out to the sides mark the normal range. Anything sitting past the whiskers, that's your outlier waving at you. But here's the responsible part. Don't just delete them. You investigate first. Is it a typo, a measurement error? Pause it. Is it a real, true value that just happens to be unusual? Then you might need to keep it and switch to a non-parametric test that can handle it. And whatever you decide, you document it. Every single exclusion, so nobody can accuse you of cherry picking. Choosing the right test. All right, let's put it all together into one clean decision tree. This is the framework I taped to my wall. Follow at the top. Step one, what kind of data do you have? Step two, is your distribution normal? What did Shapiro-Wilk and that other tongue twister say? Step three, are there outliers hanging around? Now the form. If your data is normal, it's genuinely numeric, and your outliers are clean, you go left, parametric. That's your ANOVA or your t-test. But if your data is not normal, or it's really just rank ordinal data, or outliers are messing things up, you go right, non-parametric. For comparing three or more groups, that's the Ruskell-Wallace test. And one last step at the bottom. Say your test comes back significant. There's a real difference somewhere. Great, but where? That is when you run a post hoc test to pinpoint exactly which groups differ. On the parametric side, that is Takis SDS. And it's careful not to give you false positives just because you ran a bunch of comparisons. See how every branch has a clear answer? That's what our original notice was missing entirely. Here we are. We are at the parametric toolbox. Let's quickly meet the tools themselves. First, the parametric toolbox, the powerful tests for when your data is well behaved. The independent t-test, comparing two separate groups. The paired t-test, same people measured before and after. The one-way ANOVA, your workhorse for three or more groups. Factorial ANOVA, when you're juggling more than one factor at once. Pearson's R, for measuring how two things move together. Linear regression, you're actually predicting an outcome. And Taki's HST, your follow-up after ANOVA, to find exactly which pairs are different. You don't need to memorize these. Just know they exist and what each one is for. What about the non-parametric toolbox? Well, here's the star of our show, the non-parametric toolbox. The flexible story tests for messy, ranked, or lopsided data. The man Whitney U. Think of it as the non-parametric t-test for two independent groups, Wilcoxon signed rank for two related groups. The Driscoll-Wallace H, our hero for three or more groups. The one with use on those leadership styles. The Friedman test for three or more related groups. Superman's RHO correlation, but for ranked data. Chi-square or chi-square for relationships between categories. And Dawn's test, your post hoc follow-up after Driscoll-Wallace. Notice how each parametric tool has a non-parametric partner. That's the beautiful part. No matter what your data looks like, there's always a correct test waiting for you. The ideal study protocol. So let's bring it all the way home. Remember that sad little notice we started with. Here's how we'd fix it. This is the ideal protocol. 8 steps. Anchor your variables to a real validated framework. Measure with a proven reliable instrument. Sample properly. Stratified random representative. Power. Run the numbers so you have enough people. Pre-register. Lock in your full plan before you collect data. So you can never be accused of fudging it. Screen your data. Test for normality, hunt for outliers. Choose your test conditionally, parametric or non-parametric, based on what the data actually is, and protect your participants. Ethics, consent, confidentiality, always. And that is the whole journey. We took a walk, one line study, and we did 3 things. We named exactly what was wrong with its lack of structure. We pinned down everything that was missing, and we built step by step the rigorous, ideal version it should have been. Because in the end, rigor isn't a red step, it isn't bureaucracy, it's simply how a finding earns the right to be believed. If this makes statistics feel a little less scary and maybe even kind of cool, do me a favor and hit like so more people will stumble onto it. And tell me in the comments what's a claim you have seen online that would not survive this checklist. I read those. Subscribe if you want more of this stuff. And I'll see you in the next one.